Okay. So I don't necessarily know that the rest of the content that I have is going to take the full 2 hours, but my hope is that we can finish up a couple of things related to the launch file that we've got going. And then I'll talk about drive-by-wire systems for a little bit. And then hopefully we can go out to the car, hook up the controller, and do some joystick driving with the data speed driver. The people in the back have been working pretty hard on the vehicle interface. We've got some merge requests ready, but I don't think we're going to be at the point where we can test it like right after this talk. So we'll try and get through that if we can right after I'm done talking, and then see if it works. But if it doesn't, that's okay. We've still got the data speed interface for now. So just to give you kind of an idea of how you might build a perception pipeline in Autoware, I think it would be good for us to add some ground point filtering and then some object clustering to the pipeline that we've got currently in our launch file. So let's go back to the terminal, which will be your friend for the rest of your life. Let's see. All right. So if you don't still have it open in your favorite editor, go back into the Bootcamp launch folder and open up the launch file. So this is also kind of a good point for me to go through a little bit of the architecture of the folders in Autoware. So I'm going to go to the Autoware auto repository and just kind of work through them here. So at the top level, docs is where most of well, let me correct that. Docs is where any non-package specific documentation is stored. So if there's documentation for the design of a package or for the APIs of the package, they're stored with the code itself. If the documentation is high level about architecture or guidelines or anything like that, it's going to be in docs. Source is obviously where all the source code is stored. And then tools is where things like the Docker images that get built automatically, the Clang autocomplete configuration files, which really never ended up getting used because Clang complete isn't being used in our CI pipeline. Some scripts for running coverage, for code coverage, and then some information on simulation, which I don't think this, oh, okay. They did add some of this stuff recently. So there's a scenario simulator that was created by Tier 4, which allows you to run a scenario configuration file, and it will load each of those scenarios into their simulator or into the LGSVL simulator and run that simulation and then give you a result of pass or fail for that simulation. So the stuff that's outside of those folders, all the .ade RC files are just configuration files for running different environments in the ADE Docker-based environment. And really outside of that, all you might need to actually mess with is the Autoware Autofoxy repos file. And there will be another one that will replace this soon that is the Autoware Auto Galactic repos file. And then eventually when they support Humble, it'll go to the humble.repos. So looking into source, common is mostly going to be common libraries. So you've got a lot of algorithmic specific stuff in here, some Autoware auto geometry library, a TF2 library that extends Ross's TF2, some stuff for doing covariance insertion. HAD map utilities is Autoware specific tools for interacting with Lanelet2 based semantic maps. LiDAR utils is mostly utilities for parsing point clouds and for transforming point clouds, but it's the library version of those, not the actual nodes that you'll run. There's some stuff related to measurement conversion, so converting between there's a difference between a measurement and a transform. A measurement is something that you take from a sensor, estimating the position of that sensor in space. Whereas a transform relates two origins to each other. And the measurement is not necessarily a measurement of an origin. So there are some measurement translation tools in there which allow you to, like, for example, receive GNSS data, which is a measurement, and then convert that into a transform, which can be published, and vice versa. There's some stuff in here related to neural networks. So Autoware uses a generic neural network framework called TVM. It's produced by Apache, and TVM allows you to run a neural network that was generated using any architecture, so PyTorch, TensorFlow, like any of those. You can then build that neural network, and then the compiled file can be taken in by TVM and optimized for a specific hardware platform. So it will run a set of optimizations and allow you to run that. It offers a generic API to be able to access the functions of that neural network in C++. So you can write a node in Autoware that uses TVM and say, I'm receiving camera data. I want to use a neural network, whatever neural network you choose, and I'm going to run it through this pipeline. And then when you get to the point of actually compiling it, you can choose which neural network, regardless of what architecture it was made on. And then it will run that architecture in your node. There's some stuff on signal filtering, state estimation. There's the TVM stuff I was talking about. And the vehicle constants manager hasn't been touched in a while, but that will eventually be something where you can store a set of constants about the vehicle and make them available to all of the nodes. In ROS 1, you had a parameter server. So each individual node didn't have its own parameters. There was a central parameter server, and you could set parameters globally from there. In ROS 2, each node has their own parameter, and there's no central place to store those. So if you have, like, the wheelbase of the vehicle and the track width of the vehicle and the weight of the vehicle, those things are needed in a lot of algorithms, but you have to reproduce those in every set of parameters that you want to, distribute them across your nodes. So the idea in the Autoware Foundation was to come up with a vehicle constants manager, which would just run as a node on the system to kind of act as a central parameter server. And you could query that for pieces of information when your node starts up to see, to get the common values. So that's all the common stuff. Control is mostly about vehicle controls. So there's a pure pursuit implementation in here. There's an MPC implementation. There's some stuff for testing controller nodes, running simulations, that sort of stuff. And then there's a basic trajectory follower. Drivers is mostly vehicle interfaces at the moment. There are a couple of drivers that are actually maintained in Autoware Auto. So there's an instance of a camera driver for the Spinnaker API, which is used on FLIR cameras. Then there's Autoware Auto's own implementation of a Velodyne driver. And the reason they did that is because they wanted a Velodyne driver with no dynamic memory allocation at startup. And that's a big thing in real-time systems, to make sure that you have static memory allocation and that's not dynamically changing during runtime. The Velodyne driver that's here and the Velodyne driver that is community maintained, the major differences are the one that's community maintained has a lot of additional features in it that are kind of baked into the driver, whereas this one is literally just a points translator and does pretty much nothing else. And you are expected to use other nodes to transform and modify the data after it comes out of the driver. But in the community driver, for example, you can do things like motion compensation and transforms and that sort of thing in the driver itself, just by setting some parameters. So it kind of depends on your use case. If you're building on real-time systems, I definitely recommend the Autoware one. But if you're using it just for research and development, the community one is totally fine, and the extra features are nice to have. So as far as like supported out-of-the-box vehicle platforms, anything that's running the New Eagle Raptor drive-by-wire system, anything that's running autonomous stuff, speed and steering controller, or anything that is running a VESC, like on the F-110 vehicles. There are vehicle interfaces already built for those in Autoware Auto, and we're currently working on the one for data speed. If you want to build another one, there's a lot of documentation on the vehicle interface package that's here, and there are a couple of C++ classes that you have to inherit in order to get the basic subscribers and publishers for the standard message types that are supported in vehicle interface. Outside of drivers, Fusion I don't think is actually being used anywhere, but it's got an implementation of a Hungarian assigner in it. Launch is where all of the launch files are stored that are specific to Autoware and mostly used as examples for building your own launch files. There's localization, which includes an NDT implementation and some nodes that are specific to localization. Right now, the state estimator is really kind of the core of the localization stack, and NDT is just one of the inputs to it. The state estimator is made to be able to handle odometry messages, pose messages, and whatever the output from NDT is, which I can't remember offhand. And you can extend that to handle other message types, and then it will fuse all of those and use an EKF filter to produce a pose estimate. With mapping, as I said, it's got the semantic side. So there's HAD mapping, Lanelet 2 map provider, which is what will load the Lanelet 2 semantic map. And then there's NDT mapping, which is kind of a proof of concept that allows you to generate a point cloud map just by using frame-to-frame matching. But it's really simplistic. It does not have loop closure. It doesn't do any sort of normalization of the planes or anything. It's very simplistic. So I really don't recommend using it. It's just a proof of concept. There are better things out there like Google Cartographer or Loam or anything else really. And then there's point cloud mapping, which I think most of the nodes in there are just used in NDT mapping. The perception stack is where I would say the most work has been done in Autoware Auto. So under filters, there's an off-map obstacles filter. So what this does is it takes your semantic map that you provide in Lanelet 2 format and says, I'm going to take the point cloud that I'm getting from a sensor and filter out everything that's outside the boundaries of the semantic map. So if you're racing, for example, this is great because you don't care about any obstacles that are outside of your track. So this is a really useful one to use. There's an outlier filter for just filtering out random point returns in LiDAR data. There are point cloud filter transform nodes, which are the ones that we use to transform point cloud data to a different frame of reference and allows you to merge those, fuse those with the point cloud fusion. The Polygon Remover is a fairly recent addition, and that one's kind of fun. For example, if you have a vehicle that is like a somewhat non-standard shape, you can define a 2D outline of that vehicle and then give it a point cloud, and it will just drop all the points that are inside of that outline. So that's a pretty handy one for avoiding like accidental obstacle detection because of the edge of your vehicle or something. And that Polygon Remover takes polygons that you define either at runtime or on the fly while the node is running. So you can pass it a set of areas where you want to just drop all the points because you know you don't care about them there. So it's a pretty novel thing. Then there's the Ray Ground Classifier, which doesn't work great in a lot of situations for ground classification, but if you're using a scanning LiDAR with multiple horizontal layers, it works pretty well. If you're using something like a flash LiDAR or a rasterizing LiDAR, it doesn't work great. And then there's voxel grid. So it's downsampling using a voxel grid, and you can define parameters for how big your leaf sizes are, how big your voxel sizes are, etc. Then we've got some segmentation stuff. So there's an implementation of the Apollo LiDAR segmentation neural network. So you can do, instead of Euclidean clustering, for example, you can use Apollo LiDAR segmentation to run a neural network to segment the LiDAR data instead of using the CPU. I actually don't know what ground truth detections is. That's a fairly new addition. See if the design is filled in by chance. Oh, it is. So ground truth detections converts the ground truth dynamic detections from the SVL simulator into the format understood by the Autoware auto perception module. Okay. So SVL as a simulator, as with any other simulator, is providing you ground truth data, which is not actual sensor data that you have to parse. It's literally your GNSS. Doesn't matter what you get from your GPS data, you are actually here. Or I think in this case, it's talking about camera data. So it actually provides you the semantic representations of the objects that you're seeing in the camera without having to parse the camera data. And then this will convert that into detected objects that Autoware can use in its perception pipeline. Crusted ground truth. And then there's tracking nodes as well. So tracking nodes allows you to generate tracks from multiple detected objects. So the pipeline within Autoware is you start with raw data, you pre-process the raw data with sensor nodes, and those get turned into detected objects, which are just a semantic representation of that object with a bounding box, an outline, and maybe a classification, depending on what sensor it came from. Then those get brought into the tracker, and the tracker will create tracked objects based on objects which are seen in more than one sensor or are seen in one sensor over multiple frames. And then it will also generate additional data that you can't get from single frame reference, like acceleration and velocity and stuff like that. And then the eventual pipeline after that will be the tracked objects will then go into a predictor, which will predict the estimated track, the estimated path for each of those tracks. But that part hasn't been implemented yet. So that's all the perception stuff. Then in planning, we talked a little bit about the planning architecture in that architecture diagram we went over. That included the behavior planner. Some of the new stuff, they added in a cost map generator, a free space planner. The lane planner is basically just something that turns lane segments from a lanelet 2 map into waypoints. The same goes for the parking planner, which actually they've already deprecated and removed. The lanelet 2 global planner loads in the lanelet 2 map and then allows you to give it a current pose and a desired pose, and it will use the lanelet 2 map network to traverse the segments to find the route in the map to get you from A to B. The object collision estimator just takes the output of the behavior planner and compares it against the list of detected objects. If it thinks there's going to be a collision, it outputs a trajectory that reduces your speed to 0 before the collision. Pretty simple, stop and wait for clear. And then the record replay planner is a really, really simplistic planner that doesn't use any semantic data. It literally just records the localization estimate in a CSV file as you're driving. You define how often it records the waypoints. And then once you get to the end of the route, you can drive back to the beginning and hit replay, and it will load the CSV file and just produce that as a trajectory to send straight to the controller. It's pretty simplistic. There's not much to it. The trajectory spoofer is mostly used for testing, and the trajectory smoother, it basically just applies a filter to the trajectory points to smooth out the velocity and the heading. There is a prediction set of nodes in here, but they're non-functional yet, so don't bother using those yet. System is fairly new. There was an emergency handler added a couple months ago, and its purpose is to essentially usurp the output of the trajectory planner and say, if we have an emergency in a subsystem or a sensor fails, then immediately create a simple trajectory that reduces our velocity to 0. That hasn't been thoroughly tested yet, so don't trust that for any safety critical systems. And then there's a URDF package or folder in here, which contains a couple of description packages for the F-110 vehicle and the Lexus RX 450h. And they just have basic URDF files defining the common sensor set, as well as some variables like the curb weight and the track width and the wheelbase and stuff like that that's common to those vehicles. So that's pretty much it. That's the whole structure. So the next thing that we want to add in order to start filtering our data from the ouster is we want to transform it first into baselink. So even though the transform tree exists so that you can do that, we need to transform it into baselink in most cases so that several of the nodes within Autoware assume that all fused sensor data is going to be in the baselink frame. And B, if you want to fuse that data with any other sensor, you've got to have it in a common frame. And baselink is just the easiest one for us to get to. Yeah.
If you have to add a new package to Autoware for example, for use how do you do that? What's the easiest way to do that?
So if you're using a package that's actively maintained by someone else, I'd recommend adding it to the .repos file and just make it part of source external. If you are adding a new package that you're developing new feature functionality or features, pick the subfolder under source that kind of makes the most sense. And then when you make the merge request, if one of the maintainers thinks that it needs to go somewhere else, they'll let you know, and then you just revise the merge request. It's a pretty active process. The development is very open and very two-way communication. So if there are any issues with your merge request, somebody will let you know pretty quickly. But it is worth noting, if you guys haven't seen them, that on the documentation for Autoware, there are support guidelines. So if you have any questions about Autoware, the first source is going to be ROS Answers. Go check to see if there's one that's already listed that meets your needs. If there is not, post one there with the Autoware tag. Then the second level is, if you don't get a response for more than 7 days, get a hold of somebody in Slack, try and email the foundation, etc. The Autoware Foundation is not a group that has like people on staff waiting for support requests to come in, 24-hour turnaround, none of that stuff. The foundation is open source, community driven, so don't expect lines and best practices will tell you pretty much everything you need to know for how your code should be formatted, the process for creating a merge request, who you should assign it to, how to get a hold of them, the guidelines for what version of C++ or Python that they're using, the license and copyright, all of that stuff. So make sure that if you plan on submitting a merge request to Autoware, you read through this first, at least skim over it. Otherwise, you're going to get probably an immediate rejection and say, go read the guidelines. There are naming guidelines in here as well. So if you're naming topics, TF frames, namespaces, all of that has some guidelines for what you should be doing. All right. So the transformer, we need to run an instance of perception filters. Yeah, point cloud filter transform nodes. So we want to run the point cloud filter transform node. And there are plenty of examples of that in the launch file. So we will, or in the launch files. So we will go get one. I also recommend the easiest way to see if someone else already has an example in a launch file of what you want to run is go into the Autoware demos launch and grep for the name of the name of the node that you want to run. So point cloud filter transform. Tons of them. I'm going to pick avpsim.launch.py as the one I'm going to pull from. Oh, I've actually already got that one open. So I'm going to look for point cloud filter transform nodes. So there's an example block. I will put this in chat. And we basically need to add that to our launch file. So after the ouster launch in your launch file, plop in that new block. And we are going to call this filter transform ouster. So this is to take the point cloud data from the ouster in the raw point cloud and move it from the frame of reference of the sensor to the baselink frame of reference. And so we're doing that so that if you want to fuse data from other sensors, they all have to be in the same frame of reference to begin with. And then also because at least 2 other nodes in Autoware require that baselink be the frame that the sensor data are in. So what we need to change in this block, the package is going to be the same. The executable is going to be the same. The name, we want to change that to something that's specific to our stack. So I'm just going to make that filter transform ouster. The namespace, I'm going to make this namespace just LiDAR. That allows us to keep all of the topics of it separate from the topics of the other nodes that we're running so far. But that does mean that when you run the node, all of the topics that are part of this node are going to get that namespace prefixed in them. So if you're running, for example, the ouster driver, and the ouster is outputting the data on /points, this node, even if you remap points in, which is its default name for the input topic, to points, it's going to become /lidar/points. So you have to make sure that if you want the ouster, for example, I don't know if you can apply a namespace. No, you can't. So since we're including the launch file for the ouster, and in order to apply a node namespace to a node, you have to do it in that node's launch file where that node is launched. We can't modify the namespace of the ouster node from this launch file. So we have to tell filter transform ouster where to find those points outside of its namespace. So to do that, you give the remapping an absolute name instead of a relative one. So from points in, instead of just putting points here, we have to use /points so that it's at the root namespace at the very base. And then we're also going to use our own configuration file for this. So for the parameters, we can get rid of this launch configuration option here. And we're going to make a call to our get shared file function. And then make it a launch configuration object like we did up above. So this will be launch.substitutions.launch configuration. Actually, before I do that, there's one thing that I'm going to fix that is making this a little more cumbersome than it needs to be. So instead of giving like module.module.function name, you can just say function name, and then up top, instead of import module, you say import this function from this module, or from this module, import this function. So I'm going to do that for launch configuration so that we don't have launch.substitutions.launch configuration. We just have launch configuration. So then up at the top, we need to change import launch.substitutions to from launch.substitutions, import launch configuration. And then in the one case where we did use that already inside the data speed for DBW, we can get rid of the launch.substitutions part. Okay. Back to our filter transform. So we're going to get a launch configuration. We're going to have to give it a different name for the argument, because we've already used params as the input up above, and we probably want to, like long term, you would want to make that more specific, like DBW params. But in this case, we'll just call this one filter transform params. And then we need to call our get shared file function. And as we learned last time, we have to pass that as the named parameter default. So this is going to be in Bootcamp launch. It's again going to be in the config folder. And we can call this filter transform, oops, in quotes, filter transform params.yaml. It's 2 parentheses there at the end. Obviously, this line is super long, so the linter's going to complain, so we need to break it up. And then I will also put this in the chat. Then in order to actually launch it, we need to do all the normal stuff of adding it to the launch description. And then we'll need to add a dependency on that package to our package. And then we need to create the configuration file so that it has something to read from. Yeah. So if you don't do that, then the filter transform ouster node will subscribe to /lidar/points, and the output of the ouster driver will just be on /points, so they won't be connected. So you would just get no data coming in. And you can figure that out by doing a ROS2 topic list. And then when you do ROS2 topic info -v, you can see the individual subscribers and publishers on each topic. And if you find a topic that has a publisher but no subscriber, that means the data is not being used. And if you find a topic that has a subscriber but not a publisher, that means you're not going to get any data coming in. Okay, so I think that's it for the launch file. Questions on that up to this point?
Like launching these transform nodes. This only this is one as a separate node, but better to like move them together with some like composable, like
Yeah.
composable.
Right. So in this case, because of the way that the ouster driver is written, it's written as a lifecycle node, and I don't think it's written as a composable node. Then you would have to launch them separately. If the driver is written as a composable node, it's better to have like the stuff that's only going to be publishing and subscribing to that data composed into the same process. It's more efficient that way. But there are a lot of cases where it's kind of questionable, like depending on who needs the output data, depending on, you know, because theoretically you could run one process that has every node in it that you're running in your architecture. And it's where you cut that line off is kind of system dependent and throughput dependent and a bunch of other things. So I can't give you a definitive answer, but it's kind of like analyze your system and determine what you think is going to be the most efficient. In this case, like we're going to be adding filter transform node and a Euclidean cluster node. Euclidean cluster node is very CPU intensive. I would not want to run that in the same process with other nodes. But the transform node is not that CPU intensive and it's doing something only on the LiDAR data. I'd probably combine that with another one if I had the option to here, which I don't.
If one of my node dies, does the other node still run off? Because that's the same process.
They both die. Yeah, that is one of the downsides of doing composable processes. Essentially what it's doing under the hood is it's doing dynamic library loading. And when you load a process, you dynamically load a library into a process. If you dynamically load several libraries into that process, if either the loading of that library fails or one of the threads associated with that library fails, the entire process will die. So it's just the way it's architected, limitations of C++. Yeah. I'm sorry, I can't hear the mask. So you can write a lifecycle node that is both a lifecycle node and a composable node, but the version of the API that's in Foxy doesn't make that easy to do. And so it was likely that they valued the lifecycle features over the composability of the node. I have written lifecycle and composable nodes in Foxy. The ROS2 socket can driver is a good example of that. That is both lifecycle and composable. So they can happen. They just didn't write it that way. All right, so let's save the launch file. And now we're going to copy a configuration file for the point cloud transform filter. The point cloud transform filter is a little bit unique because you kind of have two ways to provide the transform that you want to apply to the points. You can either manually specify in the configuration file, I want this offset in X, Y, and Z, and I want this orientation translation applied, or orientation rotation, this orientation rotation applied. Or you can say, this is my source frame and this is my target frame. And then it will look up the transform and then apply it to each of the points. What's the what? Sorry. Yeah, so the URDF, when it gets loaded by the robot state publisher, and then the robot state publisher runs a bunch of instances of the static transform publisher. So there are two topics really where everything transform related gets published. There's /tf and /tf_static. TF_static is where the static transform publishers publish, and /tf is where the dynamic transform publishers will publish. But the TF architecture, when you are in a C++ node, you can say, you can create a transformed listener. The transformed listener kind of hides all of that. It makes it kind of, it doesn't care whether it's a static or dynamic transform. You just tell the transform listener, listen to all the transforms that are currently being published. And then you call lookup transform and give it the source and the destination frame, and it figures out where to get it from. So that's kind of the nice thing in ROS is you don't have to manage all of that independently. You just say, try TF2, look it up, figure it out for me, and then I'll apply it. Okay, so we're going to copy out of the Autoware demos folder again. So it's in source, launch, Autoware demos, and then in this case, we'll go to param instead of launch. And there's an AVP folder in here where all of the configuration files associated with the Autonomous Valley Parking demo were created. And we are going to copy the PC filter transform.param.yaml. So CP, PC filter transform param.yaml. And we're going to go up a few levels back to the source folder. And then into external, Bootcamp launch config. Yeah. Why are they what in the config folder?
Why are they not in the config folder?
Mostly historical reasons. They should be in config. That's like the ROS standard for it, but Autoware chose during this initial development for like the first 50 packages or so to use param, and so they just standardized on it. The ROS2 developer guidelines were actually not available yet when the beginning of Autoware Auto was written. It was written for dashing about 4 years ago, I think. So it was pretty early on. All right. Once that has been copied into your config folder, we will go into the config folder in Bootcamp launch. And we'll change the name of that to ouster filter transform. Or was it filter transform ouster? Sorry? Filter transform params. Thank you. And this one we're going to have to edit pretty heavily because they did some unique stuff in this file, but it's good to look at anyway. So once you've renamed that file, go ahead and open it up in an editor. And what you'll see in here is that it actually has a configuration for 2 separate nodes in the same YAML file. So if you are using the, you guys have an issue? Okay. If you are using the named node syntax, so in this case, LiDAR front, filter transform BOP16 front, or LiDAR rear, filter transform BOP16 rear, you can have multiple nodes configurations in a single YAML file because only the ones that are in the correct order in the chain for that node will apply to it. But if you are using the /* syntax, you cannot do this because anything defined under that will apply to all nodes you pass this to. So what we're going to do is kind of convert this to the # syntax and then only use it for the one node. So get rid of everything under LiDAR rear. And then for the LiDAR front section, we're actually going to remove the LiDAR front line and then de-indent everything by 2 spaces. And then we're going to change filter transform VLP16 front to /**. Then we need to change the input frame ID to match the frame ID of the data that's coming out of the ouster, which was LiDAR scan frame, I think. LiDAR data frame, that's right, thank you. So that is going to be our input frame ID. Then the output frame ID is baselink, which is correct. The init timeout milliseconds is just a timeout that's set in the node to verify that if it doesn't receive data within the first 5 seconds of launching this node, it will automatically shut down. It should be fine. So when you run a launch file with multiple nodes in it, it's very rare that it would take more than, oh, you're talking about like the startup time for the ouster.
Yeah, based on how much time we would have like.
That's a good question. I don't know. We'll have to test it and see. The timeout milliseconds at the beginning of this is the timeout between each frame. So that shouldn't be a problem. We should never get more than 110 milliseconds per frame. I don't think. Maybe. I don't know. We may have to change that. Well, it'll produce errors if it times out. The expected number of subscribers is 1. The expected number of publishers is 1. Now, if you are, for example, if you're taking the output of this and you want it to be used by multiple pipelines, you would have to change these numbers. And the node isn't going to crash if it gets more than 1, but it will error out if it gets less than 1 after the timeout period. Mhm. It's going to publish to all of them. It will. So the ROS2 topic system doesn't care if you have more publishers than you're expecting. It's just that in this node, there's code that says if subscribers less than expected num subscribers, start the timeout timer.
So they're expected at least.
Yes, it requires at least 1.
Become 0, then one publish.
Correct. It'll stop publishing. Yep.
So it's best to leave it wrong.
Yeah, it's fine. It's fine to just leave it at 1 minimum. Yeah. And then the start angle and end angle. So you may have noticed the name of this node is filter transform. You can also crop the angle of the data that you're receiving from the sensor using this node. You can also change the minimum and maximum distance radius in this node. So we'll drop everything outside of 60 meters or whatever. So this is a pretty handy multi-purpose node. For now, I think we should at least change the min radius to 1, because 3 meters is a little far for how close we are to the sensor. So change that to 1. Oops. Max radius of 150 is fine. We won't get more than that anyway. And then the static transform publisher that's defined down here, this is only if you want to provide the transform statically and you don't want it to look up the transform. So you can get rid of everything static transformer and below. All right, save that. Again, if you're not familiar with radians, you better get familiar with radians because they're used everywhere. Actually, just for the heck of it, to make sure this is working and to see what it looks like, let's crop this to 3.14 instead. So we should only get 180 degrees of data in this case. And that should start from the x-axis. So in this case, it would be the forward axis of the sensor. So it should do the right-hand side 180 degrees of the, no, left-hand side 180 degrees of the center, because it's right-hand rule and counterclockwise is positive. It's, yeah, pi left, negative pi right, around z. But if you're looking around another axis, it's, yeah, so looking down on the axis, counterclockwise is positive. All right, save that. And let's try and build it. I'm sorry? Thank you. Edit your package.xml to add a dependency on the filter transform, no, yeah, point cloud filter transform nodes is the name of it. So add a new exec depend to your package.xml or point cloud filter transform nodes. So one thing you'll notice within the Autoware architecture, and there are very few exceptions to this, is all of the nodes and the algorithms or classes that they affect are broken into separate packages. So you will have, in this case, point cloud filter transform as a package, which contains the core C++ functionality for the node, and then point cloud filter transform nodes, which contains all of the ROS related functionality that then uses the core node, the core C++ classes to do its work. And the main reason for that is if you ever want to use any of these nodes, but you don't want to use ROS, or you want to be able to port them to ROS1, or you want any different architecture, all you have to do is change the nodes package and not the core package. The core functionality should stay the same, as long as your target system supports at least C++ 14. The only exceptions to that I can think of are vehicle interface, which was made before that rule was in place, and like one or two very small packages, which the functionality of those is so small that it didn't make sense to make a whole other package for the core functionality. Okay, now let's try and build it. So Colcon build packages up to Bootcamp launch. And you should get a handful more packages this time because there are quite a few packages that point cloud filter transform nodes depend on. So you should get 34 packages. And then once that's done, just to make sure that everything's kosher, I'm going to do a Colcon test on Bootcamp launch, which it failed. And then I'm going to find out what went wrong and fix it. Line too long. That's not surprising. So line 77. Yep. Easy enough to break this up. All good. And if you do modify your launch file, don't forget to build again. Now, I generally make it best practice to Colcon build packages up to the package you're working on. But if that's the only thing you've modified, like you haven't made any new dependencies, you haven't made any changes to dependent packages, you can just Colcon build packages select your package if you're just installing that one file that you made a change to. But in this case, we added new dependencies, so it was necessary to build the entire stack. And now I'm going to try and run it and see what happens. Okay, so filter transform ouster is getting an error that it cannot look up the transform between those two frames. State publisher. Let me make sure that that configuration file is correct. Oh, okay. So the input frame ID should be laser data frame instead of LiDAR data frame. That's why I couldn't look it up. Okay. Build again. Run it again. And it was able to look up the transform this time. Yeah. Instead of packages select. So the main reason is because we added dependencies that are other packages within the stack at this point. Like the point cloud filter transform nodes is part of Autoware Auto, and it has to be built from source. So we did build the entire stack before. So in this case, you probably could do packages select, but if this is your first time using it and you only want to build the packages that you actually depend on, then you want to use packages up to instead of having to build the entire stack. Yeah. Okay. So, new publisher discovered on this topic. Okay, so I'm getting the same error that we were having with RViz because of an incompatible topic QoS. The quality of service settings on the point cloud filter transform node are currently hard coded in the code for it. They're not something that you can change via parameters. And that's fairly typical. But luckily, the ouster node does let you change its QoS parameters to be something different. So all we have to do to fix this is change a parameter in the ouster config, and that will publish it with a compatible QoS for the other node. So I'm going to stop the launch file, and I'm going to edit the ouster config. And you see here, there's an option called Use System Default QoS. So there is a predefined quality of service called Sensor Data QoS, and that publishes on best effort reliability and I can't remember the name of the lifetime, but best effort reliability is not that common. Most sensors will, or most nodes will expect reliable reliability. So this will just change it to use the most common one, which is reliable reliability. We'll just change this from false to true. Then we build again. It's in the ouster config.yaml. Yeah. Now we don't get an error for incompatible QoS. But actually, we have to wait until the driver starts up, and then it'll tell us. Yep, there we go. So now it's active, and we're not getting an error in QoS. That error also tells us that the topics are hooked up correctly, because if that error wasn't there, then it's because the topics were not hooked up correctly. So now we can ROS2 topic list. We get a whole bunch more topics. Actually, not that many more. But the important one that we're seeing from the output is LiDAR points filtered. And we can check to make sure that that is publishing data with either ROS2 topic echo or one we didn't talk about yet, which is ROS2 topic hertz, which will just tell you the frequency at which data is being published to that topic. "10 frames per second-ish. So let's hit RViz2 and look at the filtered data. So the filtered data is, should be in baselink. So we can jump to, in this case, we can use pretty much any frame that's on the vehicle because all the frames are being published and the transforms are being published between them. So you should be able to look at the sensor data from any frame. But I'll show you what the actual difference looks like. So if we start from the laser data frame, and then we add the raw LiDAR data from points, make these points so we can see them a little better. And then if you're going to add multiple topics that are of the same type, I recommend selecting them and then hitting rename. For example, this one we can just call raw data. And then you can add a second one, which is going to be our filtered data coming from LiDAR points filtered point cloud 2. Now, you may not have noticed any difference there, but that's because all of the points should be exactly at the same space as the points you're seeing from the raw data. It's just that half of them will be doubled. But we can turn off the raw data, and we see half the data. So that's exactly what we expect. It's filtering 180 degrees from, should be Z, or should be X. Yep, X positive, right around here. There we go. Now, we are currently looking at the data in the frame of reference of the sensor. Because we have an offset applied in the transform between baselink and the sensor frame, if we look at this data in baselink's frame, we should see it from the point of view of the car. And now you can see the data is shifted up in Z and it's offset by a small amount rotationally in yaw. And that's because of the transform we defined for where the sensor is located relative to the vehicle. So it's all working surprisingly as expected. Yeah. Oh, was it just 1 meter Z?
I don't know.
So it's defined by the transform that's in the URDF.
No, the min radius.
Oh, the min radius. Yeah, I think I set it to 1 meter.
So is that like, how could it like that?
So it's what you'll see is that it is it's actually not detecting anything within 1 meter. It's just causing a shadow out beyond that. So my hand is creating a shadow, but there's no points from my hand being generated there. Right. Once I get out to 1 meter, my hand should appear, yep, right about there. See all the streaming points off the edge there? So once I get inside of that, it'll cast a shadow, but there shouldn't be points any closer than that. Yeah. And that really helps with, I wouldn't recommend using this for vehicle filtering because, sorry, yeah, use the polygon filter because that was initially what we used for vehicle filtering, but the problem is when you do that, you get blind spots on both sides of the vehicle as the radius increases. So For the transform? Oh, QoS. Yeah, sure. So the sensor QoS one was in. So the sensor QoS was in config ouster config. And that was the use system default QoS. Yeah, and I can, if you want to look in the driver, I can show you like where the values, what that actually affects. Oh. Yeah, whatever. Okay, so here's the declare parameter line that's, let me zoom in a little bit. So this is the declare parameter line that defines that parameter called use system default QoS. It has a default value of false. So even if you didn't provide it in the YAML file, it would be set to false. And then that gets, this is a lifecycle node, so there's a callback for switching to the configure, the configured state. And in that, it gets set to _ use system default QoS. And then down here, that says if use system default QoS, it puts out a logging message. And then it says create a processor for the data and use RCLCPP system default QoS. Otherwise, it uses RCLCPP sensor data QoS. Okay.